Welcome to the block revolution. Today we will build the Flutter Dapp simple wallet. You will learn how to install a personal Ethereum blockchain which you can use to run tests, execute commands and inspect state called Ganache. We will program a smart contract in Solidity using VScode. By the end of this video you will have built a Dapp that is able to interact with the Ethereum blockchain. Let's get started. If you have seen any of my other videos, you know that we start by setting up the development environment. Let's do that. If you don't have Truffle, you can write on your command line to install Truffle globally. Then we will create a Flutter project. Now we need to create a Truffle project. So inside the folder, this newly created folder, write the command override test. Let's open VScode. Here we are, and here we have the directory structure. The contracts folder contains the Solidity contract file. It has these migrations that is automatically created. We will create the one that we need to make our contract. Then we have the migrations, use it to deploy the contracts. That contains the migration script files. We have the test folder that contains the test script files. We won't be writing any tests in this project. And we have the Truffle config. We will come back to this Truffle config, but for now, let's start by writing the smart contract. Inside the contracts folder, let's create a new file, investment.sol. Inside, we start by declaring the Pragma version, and we use the SPDX license identifier. The contract is called investment. We will have this for uint to 56 variables, an event that we will emit when making changes to the balance in the account. So you will have the possibility to make a deposit and withdraw from your account. If you make a deposit that is equal to 12 units, let's say, you will have immediately a return on your investment of 3. Let's take a look at the deposit function. So if you deposit some amount, first of all, we will increase the deposit by adding the deposit to the deposit value. That is a storage variable, a state variable, and also add it to the balance amount. In here, if the deposit value is bigger than the threshold amount that is set in the constructor, we will add to the balance amount the return on investment, so 3 units. And then we will emit the balance change event. In the front end, we will be listening to this to update the UI. Of course, we will also need a withdraw function. And in here, first we use the require to see if the balance amount, that is the balance that we have in our account, is bigger than the withdraw request. If not, we will emit this message. If we pass this requirement, we will deduce the withdraw from the balance and from the deposit. So in here, these two variables are used just to see how much return on investment do you have. Again, this is a bit of a sandbox kind of app. We will emit this balance change event. I will also add in here this get wallet function that is an helper function that will return the balance and the deposit values. And the contract is done. Now we will compile and migrate the smart contract. First, the compilation. Let's open the terminal and type the command, and it compiles successfully. Now, before migrating, we have to create another migration file. Inside the migrations folder, add to deploy contracts.js, and inside that file we will get the contract by its name and we will deploy it. Now we will use Ganache, personal blockchain for development. You might already know this if you have seen my previous videos. So let's go to truffle config and just get rid of all of these comments. And this is what you should have in your truffle config file. I will explain why we are using this host in here later when we open Ganache. So we have the port, and in here make sure you have this exactly like I do. Also, we have this contracts directory. This is where our contracts are located. The contracts build directory, we have to create it. I'll do that now. So in the root folder, let's go and create a set. And this is where the contracts ABIs will be placed. In here we have compilers, the compiler version, the optimizer, set this information exactly how I have it, and you should be good to go. And now we can migrate the contract. Let's do that. Now open Truffle and we will be creating a new workspace. Set the name, simple wallet, and add the project. In this place you will have to add truffle config complete path. In the server tab, change to this value and restart, and this is it. Now let's migrate. Type truffle migrate on your command line and everything should work. Here it is. You have a lot of information. Now go to the pubspec.yaml. Let's erase all the comments and add the dependencies. If you want to know more about this, check my previous videos on Dapps to see what they do. Now we add the assets because we need to know the place where the ABI is located in this investment.json file. We also add the location of the images and the .env file. And let's create a file .env. We go to Ganache, get the key of the first address, we copy it, and now we will paste it and call it Ganache private key, and we will be using this in the Ethereum utils. Don't forget to add a little line in the gitignore file so that if you upload this to GitHub, the .env file will not be uploaded and you will not share sensible information. Create a models folder inside lib, and inside this models add wallet.dart with the following content. This is a model that will store our balance and deposit, and that we will be passing around to check the information. Back to the Ethereum utils, we already have a provider. Here we have the private key that we previously got from Ganache. We have the shared preferences, so we can save the last register of the wallet. We need the ABI, contract address, deployed contract. This decoded will be for the event and the wallet model. When creating the home page, we will call this function initial setup. This listen contract will be used to listen to the events. We have this stream subscription listen event that will get us information when some transaction occurs. And now for the basic operations, we have also this get contract that is called inside the listen contract, and inside all of the other functions, the read contract and the write contract. So if we want to make a transaction, we will be calling write to contract, and this has some costs, has some fees. In here we receive the function name that we are calling, the arguments, we get the credentials, the contract, and we send the transaction. If something goes wrong, we print this message. Yes, I'm using prints. So in here in this read function, we have the function name, the function arguments, we call the contract, and we use the if client to call the contract and pass all the information. Also have this expose function to close the listener. We will be using future builder to listen to the contract, and we have this listen event that returns the stream subscription. Up here you have Ethereum utils provider and this events enum that I'm not really using, so let's comment it, because yeah, I'm using directly the name of the event. Let's check the contract, and in here event balance chain. Now down here in the function I'm creating a list so I can save some information to the prefs, that is to the device, through shared preferences. Make the conversion to int and then to string and then to list, and save that as a list, the balance and the deposit, the last deposit values. Now let's start to take care of the UI. First I will be creating a folder, Google Fonts, where we will have the font files that we are using in the UI. Again, if you want to know where I got this, please check my previous videos. Now let's go to the main.dart inside lib. Let's erase all the comments and make some changes. We have to load the .env inside the main, and we are also using the provided scope to be able to use RiverPod. Now in the My App widget, we have the title, we have the theme, and as home we have this splash screen. Notice that the splash screen is not native, and it should be integrated natively, so it shouldn't be directly implemented with Flutter and Dart. For more information on this, you can check the Flutter docs. And the app, if you record the video of the emulator while restarting, and if you slow it down, you will see a white screen while the Flutter engine is loading, and then you get the splash screen. We are using this method. It's not the best, but it works, and for this purpose it's good enough. Now add a splash screen folder, and inside create a splash screen.dart. Inside add the following content. Down here we have a splash screen widget where we set the time of the animation and the duration of the animation before we go to the home page. This is the animated logo, where we get the animation values, mainly the height and the width of an image, and the text that will be changing in the beginning. And down here in the splash screen we are then setting the animation duration and listening to the status, and after some time we are navigating to the home page. Here we have an image inside a container, and below we have a logo widget that receives the animation value. Now let's create the home page to have some place to go to after the splash screen. Add the following code. In here we are using this unfocus so we can get out of the text field by tapping outside of it. You will see that in action. We have a container with an image that will be the background image, and we have a column with a container for some space in the top. We have the logo, and we have this wallet functionality widget that will have the information about the wallet and the text field and buttons, so we can input the values to withdraw and deposit. Now let's create the logo.dart inside the lib folder, and this is basically an image and text. So we have a stack with an image below, and above it has a simple wallet text with some shadow. Let's set const to see VScode stop complaining up here, and we can now import the splash screen, and let's create the wallet functionality. So in this widget we are receiving the deposit and withdraw controller, so the values that are input, the values there are inserted in the fields, and we need an input form because we will be reusing a widget input form for both functions. Here it is. We have a form type enum, and this input form type, we have a form type enum, deposit or withdraw, to make to see what operation we should do. We use a hisDeposit bool below on the onPressed function. We check if we are making a deposit or withdraw. And then here we have a column with a text form field and all the cosmetics, and we also have a custom button that we will be creating soon. And in here on the onPressed function we check if we are making a withdraw or deposit using the constant file. And we are using the Ethereum utils provider, calling the write to contract function and passing the correct function depending on the isDeposit bool value. We can import it. In the Ethereum utils you can see that we already have the provider. After that we clear the text controller and we are quitting the text field. Let's create a custom button. So it is basically it has basically an elevated button with opacity and the padding and the text, and the onPressed void callback will respond depending on the isDeposit value. Now let's create a wallet info.dart. We import the wallet model as well as the Ethereum utils, and inside the init state we have this check saved value function, and in here we are checking if we have something saved from previous usage. If not, the wallet model will have 0 for deposit and it withdraw. Down here we are checking the state of the connection. If it is waiting, we'll have a circular progress indicator. If we have an error and a snapshot, we will show the text error, and if the connection is done and the snapshot is not null, we will assign the received information to the wallet model variable through creation of a new instance. And then we pass that variable to the balance widget. Let's try it out. I made some changes to the smart contract, so before we were taking the withdrawal from the deposit value, it made little sense because at some point the deposit value would be different from the amount, and the require is only checking for the balance amount. So now we are making the deposit value 0 when making any draw, and when we make a deposit we will assign the deposit value to the deposit value variable, and it makes more sense that way. And in UI we are showing the last deposit only. If you try to run the application while debugging, you might run into some problems like the connection closing and similar stuff, but otherwise everything should work. If you have some changes, suggestions, make them in the comment section. Make sure you like and subscribe so you can be notified when I upload the next video. Thanks for watching.